Hydrogen is the primary constituent of the observable universe. While oxygen exists in the interstellar medium, it is typically found in trace amounts, rarely exceeding a concentration of 2%. This scarcity is a matter of chemistry. In the vacuum of space, free oxygen quickly binds with ambient hydrogen and dust, freezing into water ice. In 2018, a team of 3 astronomers began a survey of the Andromeda galaxy. They expected to map the standard distribution of gas clouds that characterize the outer edges of our nearest galactic neighbor. To detect faint signals, the team utilized long-exposure imaging. Similar to the way a human pupil dilates in a dark room to gather more light, the telescopes remained open for hours, collecting enough photons to reveal objects invisible to the naked eye. This was intended to be a routine mapping of hydrogen structures. Instead, the resulting images revealed a formation that contradicted standard chemical expectations. The observation began with an H-alpha filter, a tool tuned specifically to the red wavelength of light emitted by common hydrogen clouds. When the team swapped to an O3 filter, isolating the specific blue light of ionized oxygen, a massive glowing structure appeared where they expected empty space. This structure spans 100,000 light-years, roughly 10 times the diameter of a typical nebula. This data readout shows the chemical composition: 0 traces of hydrogen, with ionized oxygen accounting for the entire signal. The astronomers were forced to re-examine their raw data. They were staring at a giant, isolated oxygen cloud that, according to the laws of binding chemistry, should not be able to exist in a vacuum. A discovery on this scale forces a choice between 2 outcomes. Either the calibration of the telescopes was compromised, or the established models of cosmic gas distribution have missed something significant. When the team presented their findings, the scientific community and the U.S. government rejected the data. They officially classified the discovery as an erroneous result. Skeptics argued the blue signal was a localized error. Because modern cities emit significant blue light, the prevailing theory was that the telescope had simply captured terrestrial light pollution reflecting off the atmosphere. Based on this assumption, the data was set aside and excluded from broader astronomical research. Rule-breaking observations require a higher standard of mathematical verification. Proving the cloud was real would require a new, independent set of eyes and a more rigorous imaging process. Independent astronomer Bray Falls took up the investigation. He deployed a Takahashi reflector, designed to maximize light collection, and a CMOS camera sensitive to a wide spectrum of light. Falls began image stacking, capturing 15 hours of exposures for overlapping data. An algorithm mathematically cancels random background noise, leaving only consistent deep space signals. Through continuum subtraction, standard blue light frames are superimposed over the O3 data, isolating and permanently removing terrestrial light pollution. When the subtraction was complete, the bluish-green oxygen cloud remained clearly visible on the image. This rigorous methodology bypassed the potential for human bias or equipment error. The data confirmed it. The oxygen cloud was a physical reality. Confirmation of the cloud's existence raised a new question. What physical process could generate a pure oxygen structure of this scale? In a star's core, gravity fuses elements in a chain. Hydrogen becomes helium, beryllium, carbon, and eventually oxygen. In low-mass stars, gravity can't fuse elements past oxygen. The core destabilizes, ejecting its outer layers in a sudden explosion. This type of supernova event would explain why the cloud is composed of pure oxygen and lacks any trace of hydrogen entirely. For a brief moment, scientists had a potential solution. The anomalies seemed to fit into an existing model of how stars end their life cycles. However, that model requires a specific piece of evidence. A supernova energetic enough to create a cloud this large would leave behind a massive field of superheated debris and a lingering thermal signature. Thermal scans of this region revealed the exact opposite. The area containing the oxygen cloud is freezing cold, showing no signs of recent stellar heat. The paradox remains. Astronomers found the exact chemical signature of a massive explosion, but no evidence that an explosion ever occurred in that sector. Advanced imaging allowed us to prove the cloud is real, but its physical origin remains completely unknown. Even in our closest neighboring galaxy, the universe follows rules that we have yet to fully define.